Hello, everyone. This is episode 4, and actually the last video that you're going to watch. I decided episode 5, I'm going to give you practice questions, and then we'll see how you do on the practice questions without any instruction. And then if we need instruction, we'll take it up there. So our last video is about making an argument using claim, evidence, reasoning models. So we're going to define claim, evidence, and reasoning, and then we're going to look at an example in a sciencey experiment or almost a physics experiment. So a claim is a statement that answers the question that's being asked in the experiment. All right, so let's go down and do that first. So here we have an experiment. It says, in an experiment, a company is testing if the weight of a bat determines how far the ball can be hit. So if you've ever seen a baseball game, they swing bats to hit the ball, and they can measure how far the ball travels at baseball stadiums. To perform this experiment, a company has a person hit the ball off the tee 10 times with bats of different weights, and then they measure the average distance the ball travels. So if we were doing our previous, in episode 2, we identified independent and dependent variables. Our independent variable would be the weight of the bat, and our dependent variable would be the distance that the ball travels. And really the question that we're trying to answer is, how does the weight of a bat affect how far a ball can be hit? So our claim would answer that question. And right now we don't have, your claim is a prediction. It doesn't necessarily have to be right. So you can make the claim that if the bat is heavier, it will be able to hit the ball further. You could also say if the bat is lighter, it could be able to hit the ball further. Or the other option is that the weight of the bat does not affect how far the ball can go. All right. So I have a set of data here that I made up as we scroll down. And we're actually not going to answer this question here, so you can delete it or cross it out. I'll get my pen to cross it out. All right. So I made some data. Here's the mass of the bat. Baseball bats in the United States are measured in ounces, metal bats. And then here is the distance. So if we were going to make a claim that this data supports, well, we actually see that bats that are in like sort of the mid-range of the bats hit the ball further. And actually the heaviest bat makes the ball go not as far. And we kind of talk about this at some point, why that might be. But how would we write a claim that is supported by this data? Well, our claim here would be, again, my little text, bats in the middle range of weight will hit the ball the furthest. Now, you might think there's lots of error in this experiment, like it has to be the same person. Sometimes they swing different, but that's what our data shows. Now, your evidence, if we go back up to the top, your evidence is what you saw in the data or what you observed that lets you make that claim. And when you're giving evidence, you want to give numbers. Okay. So what I would say here is evidence. Okay. Usually data in the form of numbers. The lowest weight bat hit the ball. And we're going to go down and give the actual number, 200 feet. A bat of medium weight hit the ball, and I got to go back, not hit the ball. A bat of medium weight hit the ball. Let's see the one that's in the medium, which is right in the middle, 236 feet. And the heaviest bat hit the ball when you go down, it's 195 feet. All right, so now the hardest part is the reasoning. Okay. So the reasoning can be one or two things. If you know the science behind it, which we don't yet, you can explain, well, why is that the case? But it explains why do those numbers support the claim, okay? And usually it's so easy, it's hard, that the middle range bat will hit the furthest. Well, and our reasoning here, if we take a look, sort of explain directly what the data means, okay? So the bat that was in the middle in terms of weight hit the ball further than the lightest bat and the heaviest bat. Now, when people make arguments, it's their reasoning that sometimes is faulty. So evidence is just a statement that's true, okay? How you connect your evidence to the claim is where people can make different claims. And you saw that a lot with COVID. What I want you guys to do is take a look here. I gave a link to sort of this article, which is not really a scientific article. It's more of like argumentation in like a social studies class or just in general. So here, what I would like you to do and just like on your own, is sort of watch this commercial, which is about Doritos and a cat. And the question is, what happened to the cat? And the person makes the claim that the dog killed the cat, and they support it with evidence, and then they give a reasoning. So they're really working on the reasoning area here, which is usually like the easiest, but also the hardest at the same time, because sometimes it's so obvious. So I would like you to play this video and then read this text as sort of another way of looking at what a claim, evidence, and reasoning is. And then there is a quizzes to do on this. And then you have one more lesson where you're going to answer some questions about calculating a rate on a graph. If you get above an 80, you'll get extra credit, but you do get credit for completing the assignment. All right, guys, this is the last you're going to hear my voice. I will see you guys on the 29th.